Good day, math folks. Today I am here to talk with you a little bit about properties of exponents. It's Mrs. Vernon here talking again about properties of exponents, and we want to look at how these properties of exponents are going to affect us in the future of our course. Properties of exponents for what we're looking at today are going to be focused more on simplifying, but these same properties will apply in other contexts such as power functions, polynomial functions, and even in our trigonometry unit. So it's really important that you have a good base foundation when we're discussing these properties of exponents. The first thing I'd like to define for you is what exponent notation is saying. Exponent notation is the a to the n term, and what it says is it means a times a times a n times. So this is the expanded form, or what I will call later on writing it out. And this is the exponent notation, that a to the n. Now, a more concrete example would be 2 to the third is equal to 2 times 2 times 2. All right, let's take a look at some of those properties. The properties that are going to govern all of our exponent problems, there are many of them, so we're going to try to break them down with some more concrete examples. Keep in mind that numbers are oftentimes more challenging than what it actually is when working with variables. This is kind of one of those cases where numbers are actually more challenging sometimes. So the first property is known as our product property. Our product property says that if I have two exponents that have a common base, I could write this out as 5 to the third, so 5 times 5 times 5, and 5 to the fourth, 5 times 5 times 5 times 5. This could all be simplified back to 5 to the power of 7. Now another way to do that would be just to say 3 plus 4 is 7. So the shortcut says we add those exponents together. The next property we have is the quotient property. The quotient property says that if I have the same base and I am dividing them, I could write it out as 3 times 3 times 3 times 3 times 3 divided by 3 times 3. And then as we go through and do this, we're going to see that, oh, those two go away, those two go away. Now we're left with 4 threes, which leaves us with 3 to the power of 4. Okay, the shortcut to this would be to take 6 minus 2 equals 4. And again, notice that we keep that same base just like we did in the problem above. Okay. The next property we have is our zero property. And this is just a really common rule. It says anything to the 0 power equals 1. And it all comes down to and is defined by this concept of dividing. We'll go through a little exploration of that in class tomorrow. The next property we have is our negative exponent property. Negative exponents are not allowed when dealing with our exponent problems, so whenever you see an exponent that has a negative on it, if it's on the top or in the numerator of the fraction, we're going to send it down to the denominator and make that exponent positive. Another way to write this would be to say 1 over 49 because 7 times 7 is 49. Now, the same rule applies if there's a negative in the denominator, we would send it to the top and make it a positive exponent. The next one is one of our power rules. What it says is 4x squared would be like saying 4x times 4x, which is 4 squared times x squared, or 16x squared. What we're really doing is we're taking that 2 and we're bringing it into each number or each term inside of the parentheses. That's the shortcut. And the next one we have, very similar. This was with a product. Now we're with a quotient, but the same idea applies. That 2 is going to be affecting both the numerator and the denominator of the fraction, giving us 3 squared over x squared, or 9 divided by x squared. And the last one I have for us here is another power property, but it says power to a power, we're going to multiply. So what we did here was we said x squared is x times x, and then we did that 3 times because this was the power of 3. That leaves us with 6 x's, or x to the power of 6. The shortcut property for this is to take the two exponents and multiply them together. Okay. Now, these were all concrete examples, but you will find that sometimes it's easier to take a look at properties that are in just their definition form. So again, just summarizing what we just did, u to the m times u to the n is u to the m plus n. That's our product property. Our quotient property says that we're going to subtract the m and the n. Our zero property just says anything to the zero is 1. Again, we'll explore that a little bit deeper in class through an activity. Anything to the negative exponent is sent to the opposite location, so this one sends that u to the denominator. Right now it's in the numerator. And then we have our power properties. Here, this one is where we're distributing that m into each term. Here we're multiplying, power to a power we multiply. And again, our quotient where we're bringing that m into each term. One thing I want to point out over here is that shortcuts are just that. They are shortcuts. Not all shortcuts are beneficial. Sometimes you need to write it out. So my usual saying is, when in doubt, write it out. Students make far less mistakes this way. Let's take a look at a couple examples. So here I have 3 examples that I have listed here. I'd like you to take a minute, pause the video, and try these on your own. Try to apply those properties, and then when you're done trying them, go ahead and hit play, and I'm going to now go through what those answers are. So with each of these properties, again, I'm going to show you the writing it out. When in doubt, write it out, the longhand, and then I also will show you it using the shortcut rules. So the first one is just a product of 2 terms. We have a's, b's, and constants in this problem. So when we look at this, the first thing I'm going to do is I'm going to take and I'm going to multiply those constants together. That's 2 times 5. And then I'm going to go ahead and write out what I have. So a, 3 b's for b to the 3rd, 2 a's for a squared, and 5 b's for b to the 5th. Then I go ahead and I say 2 times 5 is 10. I have 3 total a's, and I have 8 total b's. So my final answer is just this down here, 10 times a to the 3rd, b to the 8th. Now with our shortcut rules, we do the same thing with our constants. 2 times 5 is 10. The first a has an exponent of 1. It's not visible, but it is there. The second a has a power of 2, so 1 plus 2 is 3. And then b, 3 plus 5 is 8. This is an example where shortcut and writing it out really kind of a wash in which one is better to use. Let's take a look at b. Now b is a little more complicated because we do see we have these negative exponents. Let's take a look at writing it out first. So the first thing I did was, you'll see that I did take that u to the negative 1 and I'm sending it up top, and then I have that v to the negative 2 and I'm sending it to the bottom. Those negative exponents can't exist where they are, so we have to send them to the opposite location of where they're sitting. I kind of use the analogy, if you're negative and you're grumpy, you're not going to stay where you're at. You're going to change your location to a new spot in the house. So in this case, we're moving to the top or we're moving to the bottom. So when I did that, I had u squared, so u times u, and then I moved that u from the bottom up, so we have times u, and then we had 3 v's on the bottom, that's here, and the 2 v's from the top that got moved to the bottom are listed here, giving us our final answer of u to the 3rd, v to the 5th. Now, if I want to use my properties, it is a little bit more complicated, especially if you're not very strong with your negatives, but we can apply those rules, that quotient rule, which says the top, so u, 2 minus negative 1, which 2 minus negative 1 is 3, and then v, negative 2 minus 3 is negative 5. Well, we have that negative exponent. It can't exist where it's at. It's grumpy. It needs to be sent downstairs or to the denominator of the fraction. And now we get our final answer here. Again, this is a case where I actually think it's easier if you use that writing it out and that technique of switching their location right away, because you make less errors on that small, simple algebra that sometimes we get caught up on. The last example I have for you is listed here. Now this one, I would like to point out that it does have that negative exponent, so I'm going to address that right away by simply flipping this fraction. So when you look at my explanation, you're going to see that the very first thing I did was I took that 2, moved it to the top, and the x squared to the bottom. The next thing it says to do is it says we are cubing it. So writing it out means I'm going to write out 2xx. 2 divided by xx. 2 divided by xx. 2 times 2 times 2 is 2 to the third. I have 6 x's for x to the 6th, and 2 to the third is 8. So our final answer here would be 8 divided by x to the 6th. Let's go ahead and take a look at this one with the properties. So the first thing I did with this property, again, I did choose to flip it. I think that's a really great technique to use, especially for students who do struggle. You could just bring this power in as we do in the next step, but I think it's really a nice technique to do that switch. So after we did the switch, the next thing we did was we took that exponent and we applied it to both parts. Applying it to the top just leaves it as 2 to the third. On the bottom, it's x squared to the power of 3, which means we power to a power, we multiply. When we finish expanding it, we get 8 divided by x to the power of 6. Now, again, I know that exponent properties can be super challenging, especially when we start to mismatch and mix them all up. But keep practicing, and in the end, they will get a lot easier. I hope you found this video helpful when you are going through your properties of exponents. Thanks for watching.